¿Qué tal? Bienvenidos. Ahora vamos a tener una charla con un invitado de lujo, Greg Kroah-Hartman. Mi nombre es Hernán González. Yo soy un desarrollador actualmente de DevOps, pero hace unos años introduje un par de parches en el kernel de Linux y hará 5 años di una charla en este mismo evento sobre cómo meterse en el mundo open source y en el kernel. Así que este año contamos con la presencia de Greg. Para quienes no lo conocen, deberían. Greg es uno de los principales mantenedores del kernel, de la versión estable de Linux, y es quien hace que al menos uno de sus dispositivos funcione correctamente como anda hoy. Si no, su computadora, su teléfono, quizás su lavarropas. Linux está en prácticamente todos los dispositivos. Así que no deberían dejar de escucharlo. Welcome, Greg. Can you hear me?
Hi. Yes, I can.
Cool. So, first of all, thank you for being here. It's an honor to have you in this talk. I never imagined that when I submitted those few patches 5 years ago, I will be having this talk with you, and it's really an honor.
Oh, good. Well, thanks for having me. I'm glad to do this. It works out really well being remote.
Thanks. So first of all, I wanted to ask you, we have a really broad audience today. We have web developers, AI developers, UX designers, people from marketing, everything. How would you explain what the Linux kernel is to them?
It's really easy. I make your mouse move work. You move the mouse, it makes it work. But no, in general, an operating system is really a way to make the physical hardware look like a unified platform so you can write programs for it. So Linux is really nice. You can write a program for it on top of Linux, and it works on any hardware that Linux works on. So the program you wrote 20 years ago on really, really old hardware will still work today on modern hardware because Linux is that compatibility layer underneath. So we make the hardware work for you, and we present it in ways that you can find a mouse. And if the mouse changes to a different type, like a Bluetooth mouse or a USB mouse, you don't care. It just works for you. So it's that layer that's really low level, just talking to the hardware, making it look uniform to you.
Cool, thanks. So I know getting to that point of making it transparent to the user has been a rough way. I know, just a few years ago, I upgraded my computer to use Wayland and Pipewire, and everything broke down. How's the kernel doing these days? I mean, there was...
Well, that wasn't the kernel. So the kernel just provides the layer on top, right? So the fun thing about like sound, for instance, old systems had one sound device, right? One speaker, one in, one out. Now we have dynamic devices. I plug in a USB headset, you plug in a USB speaker, you plug in this. So you have to handle dynamic number of devices and such. So over the years, like we started 25 years ago, we converted the kernel to be dynamic. Then it's up to user space to present all those devices to you in a unified way. So ALSA provides the kernel layer above it. You have to write some fancy code above that, like Pipewire to give you different ways. Pulse audio used to be the different way. And the thing is, I mean, everything we're doing is brand new, right? We're not copying anybody. We passed all the other operating systems a long time ago, unfortunately, so we have to make this up as we go, right? So finding the proper abstractions and models and ideas of how to do this is hard. And also is a nice way, and then we have more than one device. And Pulse audio is another really good way, but then there's other different types of audio, devices after that and other use cases. So the developers learned from that and created something new based on that. And it's just a different usage model. But yeah, then getting your distribution to plumb it all together and work properly is difficult. I would suggest and I highly recommend people will use a rolling distribution that does lots of little incremental changes all along the way instead of these big 2 to 4 years upgrade the world and see what breaks. That's much, much more difficult, and it's harder to get working, to be honest.
Yeah. I've heard you said that you spend most of your day going through your emails.
Yes.
Do you have time to design these new ways of handling the system, the audio, for example? There's a kind of whiteboarding session for the Linux developers, or is it everything?
Occasionally, yes. I mean, so I'm a maintainer, and a maintainer is like we own a certain part of the kernel and a subsection. It's been compared to an editor. So we used to be a writer in the past, and all we do is we take stuff from other people and we say, hey, look, why don't you make this change here, make that change here, do this a little different way, and come back. And then because we were writers or programmers, we have our own little projects on the side to do our own things. My projects on the side are basically cleaning up low-level stuff to be a little more easier to use over time. Every once in a while, we'll get together in a room if we do have a big, difficult problem, and we will whiteboard it or stuff like that, or we'll talk online. The Linux Plumbers Conference is traditionally where we do that. We just had that about a month ago in Ireland. It's been 2.5 years since we've had to do that, been able to do that in person. We did do it virtually, and it worked okay. In person was great. We got to sit down, hash out a bunch of different things, and you're already seeing the changes that are showing up on the mailing list already based on the results of those discussions, which is great.
Mm-hmm.
So.
And the pandemic situation, did it change the dynamic a bit? I mean, for me, it was the years I worked the most. I don't know how.
Well, I mean, we've always, so the kernel development has always been done remotely, right? We all work remotely. Linux Foundation is remote. There is no office. There's never been an office. I worked for SUSE, and we had a team all around the world, and we all worked remote. So I've been doing the remote work for a very, very long time, and I'm used to doing this. And the kernel developers are really, really good at that.
Yeah.
So for our point of view, it was not an issue. It didn't slow down. We picked up really well. Lots of contributors came in. We still had a huge number of new contributors. We have like 250 to 300 new contributors every 3 months. And we have 4,000 to 5,000 a year total developers. I mean, we have huge number of people contributing. So no, we didn't slow down. We kept our insane rate of change going very, very fast. We're going like 8 to 9 changes an hour, 24 hours a day, 7 days a week. No, so it didn't affect us at all. But most of the work that we do is just getting new hardware to work. So when the new hardware slowed down for a little while, we were able to catch up on some stuff. But if you see companies are announcing new hardware, there's new changes coming all the time. So our work is never going to be done because hardware keeps changing.
Yeah, I mean, I've been outside of this world for a bit now, but everything seems a bit more stable from outside. I know you introduced some testing to the kernel that when I submitted the patches were just not there.
Yeah, we have lots and more testing. But I mean, it's also how close you are to the situation, right? All I see is bugs, right? People report problems to me all the time. Yeah. I'm reminded, so my daughter is at medical school and working in a hospital, and she's like, I'm amazed that the human body works at all, because all she sees is people with problems, right? Yeah. But you don't see all the solutions. You don't see all the systems that just work, right? You don't see all the people that are healthy all the time. And there's a lot of healthy Linux institutions out there and working really, really well. So we see the corner cases, the oddities and whatnot, but most everything. I mean, but there's like my hardware, my desktop and laptop has just worked for the past 5 years. So there's no problems there.
Yeah, cool. I knew that on the Linux 6 version, Rust was introduced as a language to write device drivers now.
Well, so our version numbers are kind of unique. We've been doing this for a long time. We just keep incrementing the numbers. So it's 4.1, 4.2, 4.3. And then when we get to too high of a number, we'll just roll over the top number. So like from 4.20 to 5.0, it just meant another 3 months had passed. 6.0 came out a couple weeks ago. 6.1 will be the next one in about 3 months. 6.1 is where Rust is. Rust has been added to the kernel, but just the basic build infrastructure. All it can do is print out literally "Hello World." That's all you can do in Rust. There's no other functionality there, nothing other than that. But getting the build to work, it was a non-trivial task. In my testing locally, I did have it working, but now the stuff that got merged, my system doesn't build Rust anymore. I need to figure that out. It's very tricky. There's an article in Linux Weekly News on how to get it working properly. But it's a great start. I mean, it's a good idea. Let's see how it goes. let's see what happens.
Yeah, and how do you feel
Yeah.
about it? Are you excited about getting a new language? I mean, you've been
It's a new language I
writing,
have to learn, right?
yeah, you've been
So
writing in
I
C
have the
your whole
books
life.
somewhere. Yeah, I've learned, but I use C every day of my life for the past 30 years, right? I learned something new about C the other day, which is kind of
Yeah.
scary. There's a lot I need to learn about Rust. That being said, it's interesting. Give them a chance, right? There's a lot of things that Rust will prevent you from ever having problems with, right? So let's try and see that. The thing is, people always are saying, oh, it's just for drivers. We'll just use it for drivers. But drivers are the most complex, intertwined, dependent piece of an operating system. Drivers rely on everything else. So you have to have all the rest of the kernel available for you in order to get a driver to work. Because drivers deal with memory, drivers dealing with I/O, drivers talk to hardware, drivers deal with timers, drivers deal with everything. So providing the plumbing, that thunking layer between the C code and the Rust code to do a driver is a non-trivial task. So we do have some examples. We have a simple GPIO driver, and it's a really great example on how to write the same driver in C as in Rust. And then you can almost read down the lines and see it. It looks really beautiful. There's some file system example drivers. And as a proof of concept, somebody wrote an NVMe, which is like your storage or disk driver. And they presented the results, and they're within a few percentage points of the performance of C, which is pretty amazing. So that was just the first cut and do that. So over time, we're going to have to create these bindings between the core kernel and the Rust code. And the trick with Rust is there's a different model. So Rust has a different idea of how it wants to treat memory and objects and such. And the kernel has its own idea of how it wants to treat memory and objects and such. And pushing those two together is a little friction. And we're working on it and we're talking about it. But the cool thing is some of the ideas of Rust with the way it handles that memory are really good ideas. And so that's actually percolating into the C code already in the kernel. So we've added a bunch of functionality in the C code, and we're like, hey, maybe we can clean up our regular kernel to not have those problems as well. So it's a little cross cultural exchange of good ideas. Whether it succeeds or not, it's going to see whether people come up with it and provide real good use cases. But it's fun, right? It's something new to do, and we like doing that. We're engineers.
Yeah, it would be really cool.
Let's see what happens.
It will be really cool to see maybe the Linux developers get to contribute to the Rust language, and you get.
Well, if you notice, one of the core Rust developers used to be a Linux kernel developer.
Makes sense.
So there's a lot of depth of knowledge in the Rust language community about how the Linux kernel works. And there's also been some special use cases. I mean, Linux is at the very bottom of the stack, talking directly to the hardware. So we have a very constrained area of what we can and cannot do. And in order to get Rust to work properly in that type of environment, they've had to change the language, which has been good and interesting to see, because then other embedded systems can also take advantage of those functionality and those features. I mean, we use C because it gives us this type of control that other languages do not. Mm-hmm. And Rust has had to add some features in order to give that type of control. Yeah. So the ideas are going both ways, and it benefits all communities that way, it's fun.
Cool. Do you think having a new language introduced to the kernel will attract new developers? Maybe a new generation?
We have so many new developers. Are you kidding me?
Yeah, but I mean,
what do you mean
I
new
don't
generation?
know.
We have. I mean, I talk to universities. I live in Europe now because I work a lot with universities. We have so many new developers every single 3 months. We have 250 to 300 brand new developers every 3 months. Most projects would kill for that, right? If we get more, even better. But I mean, there's more people doing operating system work today than there ever has been, which is great. We have 4,000 to 5,000 people a year working on the kernel. That's more kernel developers than there's ever been in history, right? Of any operating system. So we keep getting new people all the time, and as older people don't go away. So this is great. I mean, we have a lot of depth of knowledge, and we have a lot of brand new people coming in all the time. At the conference, Plumbers Conference, there's a number of presentations by graduate students doing some really cool research on how to solve some real problems. There's a lot of good work at a lot of universities that use Linux to teach the basics of operating systems and systems designs, and we get as many people as we possibly can into our intern projects. Nice. We have more interns applying for our open positions than we have spots by far. I think I had 250 applications for 10 spots. So we have so so many people, and there's so many jobs out there. If you have any talent or any interest in working in Linux as an operating system, you can get a job. The joke used to be you get 5 patches in the kernel, you get a job. Somebody did a presentation at the plumbers conference that they said, no, it took me 20 patches because the first 10 were spelling fixes.
Yeah.
So.
Yeah, mine are the same. They're just erasing variables that were not used and fixing spelling mistakes.
But I mean, but that's a non-trivial thing to do.
Yeah.
You have to understand how the process works, the language works, and whatnot. So as long as you do that, you're instantly hireable. But yeah, if we get even more people coming in, even better. But a lot of the core people that are working on Rust are very, very experienced developers, very good systems developers writing code in Rust today. We've known about this for years. So getting their experience also in Linux is wonderful, and I'd love to have that. That being said, there's also universities writing file systems in Rust, and graduate students have presented their findings, and it's awesome. So yes, it'll be fun. Never a dull moment.
Yeah. I don't know much about the Linux Foundation. I mean, I know it's behind all of this, but
no.
I don't know how you organize and what's your role in it. I mean, what does it mean to be a fellow of the Linux Foundation?
So the Linux Foundation employs Linus, and employs me, and employs Shua Khan, so 3 fellows. But remember, we have 4,000 to 5,000 kernel developers every year.
Yeah.
So Linux Foundation is a nonprofit. It's a trade organization that companies join so that they can work together to solve common problems. Because if 2 companies who are competitors legally cannot talk, right? It's illegal for them to talk. That's collusion, all sorts of government regulations in all countries around the world. So you form a trade organization where you can come together and solve common problems and talk as competitors because you're working on a shared, open project. It's a great legal organization, a great way that companies can provide resources. So Linux Foundation provides hosting for a number of projects. They provide resources for kernel.org, which is us kernel developers. And they also provide funding for Linus and me and Shua to be independent. So we don't work for any one company, but we work for Linux. I mean, our contracts say that we can't tell Linux Foundation what to do, and they can't tell us what to do. I mean, cool. It's a trade organization where we can work to solve problems like secure boot with UEFI was going to be a problem with Linux. So we all talked to the companies, we got the good contacts, we solved that problem, and we worked together to solve that. There's also a representation. The Linux kernel community elects 10 people to be on a technical advisory board to the Linux Foundation board. And 1 person of that is actually on the board of directions of the Linux Foundation. So the Linux community, developer community, has a direct say to make sure the Linux Foundation stays true to its roots and supports Linux and wants to see the betterment of it by providing the proper resources where needed. And it's also a bridge. So the technical advisory board is a bridge between companies and the community that works really well. It's awesome. So, but we don't have any offices. We all work remote. It works out pretty well.
Yeah.
And also Linux Foundation funds and supports now a huge number of open source projects because the people at the Linux Foundation understand how this works really well. They have the legal framework in place to do like really good open networking projects, testing projects. There's so many Linux Foundation projects right now. It's crazy. PyTorch, that's very common. Machine learning project is now a Linux Foundation project. Kubernetes, it's a Linux Foundation project. A ton of cloud native stuff is there. Yep. It's a good environment where you can all work together on an open source project in an open source way, provides the resources for hosting, as meetings, as web chats, et cetera, like that, mailing lists.
Nice. It's nice to hear. I really believe that having open companies and open businesses and open source code.
Yeah, and it's a way for like big companies to actually contribute in a proper way, right? And they're held accountable by everybody else, and they're legally held accountable, which is even better. So they legally can't do the thing. And another interesting thing is like a couple of years ago, the U.S. government said these certain companies are not allowed to be talked to by U.S. companies, right? Chinese companies, except open source doesn't matter because we're working in the open. There's no contractual obligations there. So it found out, so the really good thing is open source is not able to be stopped or restricted by any one government in the world. So a lot of companies and a lot of countries realize that, and now they're even working more on more open projects together in that good legal framework that which nobody else can help stop it, because you don't want one country in the world to be able to stop projects for everybody else, right?
Yeah. Um, yeah, I don't know. My feel is that most of the tools nowadays are open, and the business model has changed. It has pivoted towards more support, giving you some platform to develop, but not the tool itself.
It depends on what you're doing. I mean,
Yeah.
the old model Linux succeeded because the people want to sell hardware, right? So they want to have they want to sell hardware, and you get Linux working on it. So that's a really good model. You have but Red Hat has always sold support. SUSE, Novell sold support for basically your systems like that. So there's a lot of different business models in what you can do with open source. And then there's like the open core, which is not really open source, but that's the whitewashing of the open source model. But that's always happened. I mean, that's been the way for forever. It's a tough. I mean, running a business is tough, be it open or closed. It's not an easy thing to do. So I feel sympathetic to them, but sponsoring. But the cool thing is you can use all these open source projects to build your company in ways that you couldn't do before. You don't have to spend a whole bunch of stuff on software and whatnot to do your ideas. We provide the tools for you to make your solution, which is the best thing.
Yeah. Changing a bit the subject here, I just wanted to say that I love that you are constantly giving talks and interviews, and that you wrote a couple of books about Linux and device drivers. And I know you're currently a consultant at the Oregon State University. What's your role in there?
So there's an open source group at Oregon State University. They used to host Mozilla, a big hosting group. So I'm on the advisory board for their little open source group that helps students learn how to work with projects and come up, and they help host lots of stuff. I mean, again, Mozilla used to be hosted there. They're not anymore. But yeah, so I used to live in Oregon, so I knew the people there, and I helped the students. So I work also a number of other universities I do a lot of work with too, as well. I'm not a consultant; they don't pay me.
Right. But you don't give lectures. They just reach you when they have a project, and you advise them, something like that.
Yeah, that one. Oregon State, I haven't. I did have good lectures. I give lectures at other universities. I did for a few months in Paris at a university there. Gave talks. I've given talks in the Netherlands here to universities. I've given talks at universities all around the world. That's great. So if you're at a university and you want me to give a talk remotely, it's really easy right now. I have really good introduction to Linux, how to get involved, writing a first kernel patch, how the whole development process works, because software engineering is a little bit different than the old model of software engineering today. The Linux kernel development model is crazy if you try and classify it. Thankfully, now people are doing research on what we do and how that actually works, which is kind of fun. Nice. But yeah, no, I don't actually teach a class. That'll be fun though. But,
yeah.
No, I don't.
Yeah, I just wanted to ask you, how do you feel about teaching? I mean, I'm teaching at university too. It's hard for me to find a balance between coding and teaching. I would like to do everything, and I feel I don't get enough depth on any.
Yeah, it's hard. That's hard to provide that balance. I don't know how to do that. It's difficult. Do you spend more time lecturing and helping students, or do you find more time to work with your own projects? That's a tough balance. There's a number of good professors out there that do both. But a lot of it is nurturing and helping other people find their solutions and get their diplomas and going off and doing good things in the world. I have a very bad habit of telling people in PhD programs, you can get a job now, you don't have to get a PhD. So watch out if I come talk to your university about that.
Yeah. What do you think would be a nice place to start as a Linux developer nowadays? I mean, I remember there were a lot of work to do in staging area.
There still is.
There still is.
That's exactly why that's there. So there's a part of the kernel, we call it drivers staging, that has drivers that are kind of messy and need to be cleaned up and need to get, there's a big to-do list in every driver on what needs to be done to get it out of staging. And we purposefully keep them there until they get cleaned up and moved out in order to have a way for people to get involved. So it's a great place. So we have, right now, there's an intern project, Outreachy, is going through its application process, and part of their process is create some patches in the staging directory and get them accepted. And that way you learn how to edit the code, how to create the patch, how to send the email, how to fix your email client because it sent it incorrectly, how to resend it when you get review comments, how to send a second patch, how to make a series of patches, just all the basic fundamentals of how to get involved in the kernel are there. And you can make just spelling fixes. You can do things like that. We have a huge number of core kernel maintainers that started in the staging directory because it's a great place to start. You always want to have a place to start. Our difficult part is finding that bridge between these easy cleanup tasks to some more intermediate tasks. It's a little bit hard sometimes to find intermediate tasks. That being said, if you just start building the kernel, on the Kernel Newbies website, if you just start building the kernel, build the development kernel every day, you'll see warnings. Hey, go fix those, and that kind of drives you down a little path into a portion of the kernel that maybe you're interested in, and you can work on that. The kernel is huge. We have 25 million lines of code. You don't all run 25 million lines of code. You only run about 3, but everybody, it's there for everybody. So little tiny areas of code maybe aren't. We have tons of unmaintained chunks of code that we would love to have maintainers for and get involved. Just talk to me. I'll point them out to you.
Nice. I recently found out that there's a thing called EBPF for running sandbox Linux. Do you think that's a nice place to start with getting involved with the kernel concepts? I mean, I know you can write your own modules that run on kernel space without actually modifying the kernel. Do you think that's a good approach to start?
I laugh because EBPF, the joke is it's taking over the whole world. It's taking over the whole kernel, right? EBPF, for what you don't know, it's a virtual machine in the kernel, and it was originally created for networking packets. So you can write little programs to help with networking packets, packet filtering, packet routing, all sorts of fun things like that. And it's grown. It's grown over time. So you can do tracing with it now. You can do lots of other stuff. Now we can write a HID driver, which is like for your mouse or for your keyboard in EBPF. Because a lot of the times, a lot of work that the kernel does is make this hardware look correct. So we have to fix up broken hardware. So writing some of the fix up the broken hardware in EBPF programs is a good idea, right? Because you don't always want that to be kernel code that everybody has to load. Make a little side thing that EBPF can load and away you go. That being said, there's a ton of good research there. There's loads of stuff. So if you're into networking, yes, look at EBPF. There just was posted on the mailing list of EBPF of how they're going to work to move the old NetFilter model into EBPF because all the spectrum meltdown problems of CPUs have slowed down NetFilter huge, while EBPF is still going pretty fast, even despite the mitigations we've had to put in there. So how to model the NetFilter stuff in EBPF. So if you're into networking, yes, use EBPF. If you like virtual machines, yes, look at EBPF. If you like compilers, yes, look at EBPF because there's really good compiler work. There's now compilers from almost any language into EBPF bytecode. I think there's now a GCC version that does it as well as Clang. Of course, it's been there since the beginning. But there's lots of exciting work to do with that. And then if you like other areas of the kernel that you're comfortable with, moving that to maybe accept EBPF as well. Like I joke USB will do it someday, but you can write drivers for USB in user space today, so maybe we don't need it. But the way the HID layer did it is a really good idea in how to do that. There were some patches posted on how to write a file system using EBPF. And there's a presentation at the Plumbers Conference. So even file system people are getting involved in EBPF. So it is taking over the world. But it's really good model. It's a microkernel model. It's a protected model. You can't break out of it. It's safe code-wise. So there's a lot of really valuable things to say for it. It's a really powerful thing. And so a lot of the old traditional model of microkernels apply to that in a way that's still within a monolithic kernel, and it works really fast and it works really well. And it's also protected. It's a good idea.
Nice.
Yeah, if you like those types of things, by all means, EBPF is a great place.
Cool. And again, changing the subject a bit, I wanted your opinion on those set of malicious patches that were introduced by the University of Minnesota last year. It's a hot topic.
It was a hot topic.
I don't know how it evolved.
Yeah, so I gave a whole talk about this. I'll point to that at the Linux, at the Kernel Recipes conference in Paris a couple months ago. And I'll let that be my definitive, here's all the past history. But for those that don't know, the University of Minnesota had submitted some patches under fake names, and they attempted to send bad patches, but the patches they sent actually were good. And then they wrote a paper saying how they had tricked the Linux kernel community in accepting their bad code. It turned out the paper was wrong because all the patches that were bad were caught, and the one that was accepted was actually correct. So they couldn't even write a bad code. So they lied to the paper review committee, and the paper review committee was mad, very, very mad. That gets into the ethics of performing experiments on people, because they were, in essence, performing an experiment on us humans, the kernel developer community, and wasting resource time of us maintaining it. They actually, I mean, some of us who got the patches, I happen to be one of the people, tried to help these people out and say, no, you did this wrong. Here, make this change, etc. Over this time. So they wasted our time from people who were actually trying to do good work. They were trying to do malicious work, right? Which is unforgivable, I have to say. The university itself didn't realize that this professor and his team was doing that. They hadn't gone through the proper review board work. So that was turned into another mess. I've worked with the university now based on this. They've instituted more strict policies. They're not allowed to contribute to the kernel. The best thing about Linux is, the best thing about open source is, we can go back in time. So we went back and audited all contributions from these people, because we knew who they were, and to make sure that we caught everything. And then we went and reviewed all their past submissions for the past 5 years it was. And we reviewed them all, and then anything that we found that was bad, we ripped out. So there's an accountability based, because you submit based on your own name, your own institution, on what you did. And open source is more secure because you can go back in time and look at what happened, and you can fix it just by that. It's auditable. So we fixed it. We ripped out a bunch of their old code. I had a number of interns from an intern project, and they helped fix them all, which was great. They got really good real-world experience of code auditing, finding bugs, and doing things. It turned out all the stuff they were doing was in really obsolete drivers. They were trying to clean up error paths that were wrong, and they ended up creating a memory leak instead of solving a memory leak. But it really was totally benign work. The university now, we have a core kernel person who happens to live in the same town and is working with the university. He's working with students and to try to teach them how to deal with open source communities and how to interact and how to work with it, because the university had nothing set up for how to work with kernel or open source communities at all. Yeah. And that was a big hole in their curriculum that they never realized that they had. So there's going to be some changes. I trust the kernel developers doing this work. I've known him for a long time. He's a really good developer, and they're going to do well. The funniest thing in all of this is my boss, the head of the Linux Foundation, that was his his university he went to. So I banned his university. Great job. So
yeah,
that's kind of fun.
It's a bit crazy.
But so they're doing good. It'll come back. It's a teachable moment, right? And people will go from that. The paper committee has now instituted much more strict rules and regulations, because they were very mad that they were lied to, and they now are working with much more ethics and better ethics in computer science research and whatnot. And there's a bunch of people have spun off and gotten a good platform. I want to call out, there's some really good people that notified us of this really, really early in the game and told us what was happening, because they saw the papers being submitted, they saw the work that was happening. So we knew about this really early in the game. And the best thing is, we caught everything they sent to us. It was really fun.
Oh, nice.
So it actually proved that our development model works. Yeah. So they didn't mean to do that, but they did. So.
Yeah. Okay. So we are almost reaching the end of this interview. Just one question from the audience that I wanted to ask you. It's about your setup. They ask you if you still compile your own kernel. What distro are you using?
So I use Arch Linux. I was a developer at SUSE for a long time, and I created the Tumbleweed. I strongly recommend any community-based semi-rolling distribution. Fedora is wonderful. OpenSUSE is wonderful. Tumbleweed's great. Debian. Debian runs the world. The majority of all systems out there in the world are Debian. So any one of those. Arch is wonderful as well. Anything that's a rolling distribution, I highly, strongly recommend that people use. Stay away from the commercial ones unless you have to for your work, and then you get paid and they'll support you. Wonderful. And they pay kernel developers. Yes, I do build my own kernels. I run my own, I run the latest Linus's tree, plus all the patches that have been sent to me and the things that I'm working on myself. I have a system call in there that I like messing around with that I've made. I run my own kernels to make sure everything works. You want me to make sure that everything works for the next kernel. On my build server, I will laugh about this. It runs Arch Linux and the generic kernel with all the generic stuff. And I'm like, oh, I can make a faster kernel, right? I compile down and strip down, and so I spent a day and made a nice, tiny, tight kernel of just the features I needed, just the options I needed, and I did all my builds and done it. No difference whatsoever. So the generic kernels that distros provide you are really, really good. Unless you are doing something very odd, just stick with them. So you don't have to make your own kernel. It works. So I tried really hard, and I couldn't even make anything go faster. So.
Yeah. Okay. Well, thank you, Greg. It's really been an honor. We have reached the end of the interview. We are out of time. Yeah, it's been a pleasure to have you. I really feel honored to have met you.
Well, thank you. Thanks for having me, and good luck with your conference.
Thanks. Bye. Bye, Greg. Bueno, y ahora seguimos con Incremental Static Regeneration, sitios estáticos con esteroides, con Facundo Giuliani. Vamos a nerdear.